Okay, hello everyone, and welcome to the last lecture. Today we are not going to cover any new slides, but we will use the time to actually solve a practice exam. So let me first make some statements. Uh, in the final exam, you are responsible for all the material which is covered, right? From first lecture to the last lecture. Uh, However, in this practice exam, we have questions related to the material which is covered after the midterm. But it doesn't mean that you will not see the questions related to the material covered before the midterm in your final exam. There will be questions, okay? So I just wanted you to I want to use this time to solve questions related to material covered after the midterm. One thing. Uh, Second, actually, I made an announcement earlier on Canvas, right? Let me open it. Yeah, and here in the announcement, I said that you can bring with you a single A4 page with notes written on both sides. Uh, so uh, in midterm exam last in the like in last midterm exam, I think I allowed you to bring the lecture slides in printed form. Is that correct? Can anyone confirm me? Yes. Okay, so is there anyone who thinks that uh, bringing the printed lecture slides is more useful in terms of like you don't need to memorize the stuff, but you only need to understand it? Or do you think that it is a lot of burden of printing them and then deciding which to print, which slides to print and which not, and it takes time and therefore A4 page is better? I mean, what is your opinion on this? Because I'm kind of thinking like maybe I can allow to let you bring the printed slides. Maybe I can actually give you both options. Okay, so it's up to you. You can, if you want, you can bring up A4 page, or if you want, you can bring the printed slides. So if you are bringing the A4 page, if you have written something on it, it should not be more than a single page, right? So written on both sides, not more than that. Okay. But if you want to bring the slides, you can print all of them and bring them. Yeah, yeah. I will give you option for the both. Let me quickly change it. Uh, Added this announcement here. Okay. Okay. Yeah. So you can like bring and a single A4 page. You can print the lecture slides. You can bring the calculator. Okay. Okay. Now we are done with that thing. Now I think we can go to our practice exam. Okay, so the pattern we will follow is like we will go one by one on through all the questions. Is it okay to ask how many questions are on the exam? I don't know because I haven't yet prepared the exam. Normally, what I do that I prepare the exam before the exam, 1 or 2 days before the exam day. So I also don't know, but I mean, irrespective of how many questions will be there, I will time them. So normally, what I follow is the following procedure. First, I solve the questions, and let's say if it takes me 60 minutes to solve it, so I give students half 1.5 time. Like you can have, I expect you to solve it in 90 minutes. If I can solve it in 60 minutes, I expect you to solve it in 90 minutes. So now, I mean, it can be like maybe 5 questions, 6 questions, 10 questions. It depends. Okay. Okay, so I hope I answer your question. So now let's start with our practice exam. So you can uh, I have shared this exam practice exam on my screen. You can read the question and start solving it. So for the first question, it says consider a floating point representation of m dot m. So you have 5 bits for the mantissa part and 3 bits for the exponent part. And if this is the floating point representation and the bit pattern you are given is 0xC9, so you are expected to convert it into the decimal form, right? So you are in the floating point value. What is the floating point value? So do it on your notebook and you have like 5 minutes for that. And let me know when you are done. Let me give you 3 more minutes and then we can have a look at the answer. Okay, so we can go to the solution uh, as okay. So for second question, so you know what we wanted to know? We wanted to know the output value, right? In decimal form. So output value is what? It is equal to if V in divided by the step size, right? So we need to first find the step size. So step size is reference voltage divided by 2 raised to power size of the out or number of the bits in the output, which is 8. So 2 raised to power 8. 25 millivolt. So V reference is 25 millivolt divided by 256. When you do the math, you'll find 0.09765 millivolt. So V out is 20 millivolt. The V out will be what? V in, which is 20 millivolt divided by step size 0.09765 millivolt. When you do the division, you will find 204.8. And when you convert to 0.04 volt or 204 into binary form, you will get 110110. Okay, so this will be your binary value you can convert into hexa, so it would be 0xcc, right? One thing here, I said 204, I selected 204.8 because definitely we cannot convert the the point 0.8 part into the fractional part into the binary form. So even like if you had, let's say, rounded it and you selected 205 instead of 204, still I will accept it as a correct answer. Any questions? No? Okay, then let's go to the next question, which is assume that we are using a 6-bit analog to digital converter, uh, and V reference is 25 volt. So if our digital output value is 55, what is our input analog voltage? So start the question, solving the question, and you have 5 minutes. And don't select that I haven't solved the question. Go ahead and try to solve, and then at the end of 5 minutes, if you are still not able to, then select that no, I haven't solved the question. Uh, yeah, Helena, we can have a look at the answer once 5 minutes are passed. Okay. Thank you for sharing your answer. Okay, so let's go back to the result. Okay, 21.5 volt. Okay, let's have a look here. Let's have a look at the answer. Okay, so digital output is equal to V in divided by step size, right? So V in is equal to digital output V out times step size. So step size we know is what VREF divided by 2 raised to power of number of bits in the output. So VREF is 25 volt. So we divide it by 2 raised to power 6. So it is 225 volt divided by 64. So you get this number. So when you plug it in this equation, so V in is 55. When you multiply, you get 21.48 volt. Okay. Any questions? I mean, is it clear to everyone? No comments mean it's clear, right? I I hope I'm still recording the meeting. Yes, I'm recording. Okay. So the next question, what is the necessary requirement? Okay, someone sent a message. Is it okay to round the nearest volt? Uh, uh, I haven't specified it in the question statement. If it is not specified, then don't round it to the nearest volt, but maybe you can round it to the like maybe nearest value in fraction like 21.5. Like for example, let's say it is 21.48, so you can round it to 21.5. Okay. So, but I will not deduct points because of like if someone rounded it to the whole number. But try to be as precise as possible. Okay. Uh, okay. Next question. What is the necessary requirement to allow interrupts to occur on the AVR microcontroller? So the answer to this question is like kind of descriptive. So what I can do is let me quickly generate a poll and you can answer it there. Okay. So PE4, right? And I can change it to short answer. And okay, yeah. Now answer it through the poll. You have 3 minutes for this question. Okay, so let's have a look at the answer. So, necessary requirement. First, you need to enable the individual interrupt that we are interested in. For example, int 0 or timer 0 overflow interrupt. And then enable the global interrupt flag, that is flag I, in the status register by executing SCI instruction. Okay. Any comments or any confusion on this question? Is everyone clear? Okay. So then let's move to the next question. Assume we have a 20 megahertz clock. What value do we put into TCNT0 to produce a delay of 7 microseconds when a timer is set up in the normal mode? You will have, let's say, you can have 4 minutes to complete this one. Yeah, we will have a look at answer in a minute. Okay, so let's have a look at the answer. So desired delay is 7 microsecond, clock is 20 megahertz. So time period of the clock is 1 over 20 microsecond, which is 0.05 microseconds, right? So the value n is the 7 divided by 0.05 equal to 140. So the value to be loaded in the TCNT0 register is 256 minus 140, which is 116. Okay. Yeah. So if you have any question, let me know regarding question 5. Okay, let's move to the question 6. Write an AVR code segment which flips the bit in the lower nibble of R18, which means the lower 4 bits of the register R18. For example, if R18 has value 0x7A, then the result will be 0x75, right? So you have 3 minutes for this quiz, this question. Hmm. Hmm. Okay, so let's have a look at the answer then. I think it was pretty easy, right? You just need to write two instructions. So first you are loading 0x0f into R17 and then simply exclusive doing the exclusive R of R17 with R18. So in this way the result in the R18 will be the four lower bits in the R18 will be flipped. Is everyone clear on this? How they will be flipped? Or you want me to explain? Is there anyone who wants me to explain how this code will flip the lower four bits of R18? Okay, okay. So actually, I think I can simply okay, let me, can I use the pointer? It says, okay, I can write the text here. So 0x0f is what? Zeros is zero, four zeros and then 111, right? And then in R18, I don't care whatever value I have in R18. Let's say I have some value which I'm writing as A, B, C, D, E, F, G, H. So I have these four bits, right? So the value of these bits can be anything like A, B, C, D can be 0 or 1, right? Similarly, E, F, G, H can be 0 or 1, right? So, so, so let's say when you do the exclusive OR between 1 and H, now if H can be anything, it can be 0 or 1. If it is 0, so the result of the exclusive OR will be what? So the result of the exclusive OR will be, why can't I write it? Okay, let me first write the answer and then I will explain. Okay, so the result will be A. Why can't I don't want to connect my OneNote by my notepad, but I think I have to, otherwise it will be wastage of time. So let me do it quickly. So so 0 x 0f is actually equal to, in binary, 0 0 0 0 1 1 1 1. In R18, I don't care whatever I value I have. Let's say, give me any value. Let's say I have value of, I'm just picking 1 0 1 0 0 0 1 1. This is R18, right? And this was R17. I loaded this in R17 and I wanted to flip the value in R18, lower four bits of R18. So 1 and 1 exclusive R is 0. 1 1 exclusive R is 0. 1 0 is 1. 1 0 is 1. 0 0 is 0. 0 1 is 1. 0 0 is 0. 0 1 is 1. Right? So the point here is that whenever you take the exclusive OR between a bit and a 1, the bit is flipped. So like, let's say the bit is B and you take the exclusive OR with 1. So the bit will be flipped, B bar or B complement. So for example, if B is 0 and you put 1 here, so the result will be 1. If B is 1 and you take exclusive OR with 1, result will be 0. So bit was 0, it got flipped into 1. The bit was 1, it got flipped into 0, right? So that's why we take exclusive OR of lower four bits of the R18 with all ones. And to keep the higher four bits as it is, we do the exclusive OR with all zeros. Is it clear? Is it clear to everyone? Okay. Okay, then let's move to the question. Next question. Uh, Let me erase this thing. Yeah. Okay. So the next is write a program which generates 2 raised to power 17 knobs. So you need to write a program which actually executes 2 raised to power 17 knobs. Okay. So let me start the poll again. Okay, here is the question and the poll. So solve the question 70. You need to write a program which executes 2 raised to power 17 number of knobs. You have 5 minutes. Okay, so let's have a look at the answer. So actually what you can do is that you can write three nested loops, right? How you can write three nested loops? Because 2 raised to power 17 is, what is 2 raised to power 17? How can I find it in my, yeah, 2 raised to power 17 is this number, right? So what you can do is that we can run a loop how many times maximum using 8-bit register? 256 time, right? So I divide it by 256. So I'm left with 512. So one loop is I can run it at maximum 256 times. So I need to run it for 512 times more, right? So I divide it with 256 again. So what I can do is that I can have three loops. The outermost loop runs for two times. The two inner loops, they run for 255 times, both of them, right? So in the innermost loop, what I'm doing is that simply I'm putting an op. So first I'm loading 2 in R16, 255 in R17, and 255 in R18. And then I am putting the loop body, single NOP instruction, decrement R18. And then if it is not equal to 0, then run the NOP again. So this inner loop will be run for 256 times, right? The next loop will be run 256 time, and then the outermost will be run for two times. So in total, you will have 255 times 255 times 2 number of NOP instructions executed. Any questions? Is it clear to everyone? Okay. So then let's move to the next question, which is what is the result in R16? Oh, the question is uh mm, some part is missing. So maybe I can go to the solution. Yeah, here. So don't look at solution. Okay. So yeah. So this is on question. What is the result in R16 and the flags for status register if you execute this code snippet? Do these two instructions. Load immediate R16 0x99. So you are putting the hex 99 in R16 and then you are adding R16 to itself. So after executing these two instructions, what will be the value in R16 and what will be the value of flags in the status register? And by the flags, we mean carry flag, overflow flag, zero flag, uh, half carry flag, sign flag, and negative flag. Okay. So if you want, I can list the name of flags here so that it's easy for you to remember. Yeah, I can put the name of flags here. Carry flag, overflow flag, sign flag, negative flag, zero flag, half carry flag. Sorry, for overflow we use the symbol V, right? Yeah, that's it. Okay. So what will be the value of R16 and the value of these flags after the execution of these two lines, these two instructions? So you have 5 minutes. Let me do the poll again for you. Not 5 minutes is, I guess, too much. Let's have 4 minutes. Maybe we can reduce to it to 2 minutes because we are running short of time and we have couple of more questions to complete. Can we keep the result in binary for R16 or do we have to convert it back into hexa? No. Since it is not specified in question, so it's up to you. You can keep it in binary or you can represent in hexa. Olina. Okay, yeah, we can have a look at this answer in a minute. Okay, I think 2 minutes are past. So, okay, let me give you 1 more minute because maybe I guess some students are still working. Okay, so yeah. So let's have a look at the answer, right? So 99 is this one, right? So when you add it to itself, you will get the answer 0011 0010, and carry will be 1 because I have not shown here in the solution, but there will be a bit out from the most significant bit uh, of the register. And okay, I will explain sign bit later. Z flag will be 0 because the result is non-zero, right? And half carry will be 1 because there will be a bit, there will be a carry from bit 3 into bit 4. Okay, the overflow flag or V flag will be 1 because the result of adding these two numbers will be greater than 255, which is the maximum you can contain into a 8-bit register. So the V flag will be 1. The sign bit, uh, uh, sorry, the negative bit is 0. Why? Because negative bit is basically the most significant bit of the answer, so which is 0. And sign bit is what? What sign bit is exclusive OR of negative bit and the overflow bit. So a negative bit is 0, overflow bit is 1. So 0 exclusive OR 1 is 1. So sign bit is 1. Okay. Is it clear to everyone? Okay. Okay, the next question is trivial. How many compare registers does each timer have? Uh, I don't want to give you any time to answer this. So every timer in at Mega 328P has two compare registers, right? So let's move to the question 10 then. So consider the following pseudocode where X is a global variable shared between the inf and .s files. right? So you need to write a complete assembly program to implement the following program snippet. So basically, it is simply a while loop. So in the while loop, you are checking two conditions. If x is greater than 10 and x is less than 100, then the body of the loop, you are simply incrementing x by 1. And once any one of these two condition is false, the while loop is broken and you reach to the next instruction after the while, body of the while, which simply increments the value of x by 10. Okay. So go ahead and try to write the code for this. You have 5 minutes. I'm not launching the poll, but you have 5 minutes to solve this. Let me launch the poll so that I can track how many students have. Yeah. So let me reduce the time from 5 to 3 minutes so that we can at least solve the next question also. Okay, so let me show the answer to the next question. So here, remember we said that x is a variable, right? And it is, I'm assuming that it is already initialized, set to some value. So here we are simply loading value of x in R16, and then we are comparing. So the question was like, there are two conditions. If x is greater than 10 and x is less than 100. So I am comparing R16 with 11. And if R16 is less than 11, right? So I'm saying, okay, exit the while, which means I want to move at this point, right? So it's fine to say if compare with 11. Why? Because we are saying x is greater than 10. So, and in comparison, I'm saying if R16 is less than 11, which is the same thing, right? And then if that condition is true, then I'm checking the second condition. In the second condition, we need to check that x is less than 100, right? So I'm comparing R16 with 100 and I'm saying branch if same or higher. So if R16 is 100 or greater than 100, then exit file, which means reach at this point, jump to this point. Otherwise, increment R16. So we are simply incrementing x by 1 and then our jump while, go back to this while label, right? And if we exit the when we exit the while, then what we do is that simply we don't load 10 in R17 and then we add R17 to R16 to do x is equal to x plus 10. Okay. Any questions? Okay, we have like 2 minutes left, but let me at least uh, share the next question. So in the next question, you need to declare byte arrays A and B both with the size of 100. Make sure you make them visible externally and then write a method do it which is visible externally. The do it method is to implement the following. AI is equal to BI plus 1 remainder 256, right? That is for the entire array A. Basically, we are adding 1 to the to each element in B and placing the value into the corresponding slot in A. Recall that adding to a register will automatically perform modulus 256. Why? Because we have an 8-bit register, right? So if there is any value which is greater than 255, so once it reaches 255, then once it is incremented again, all bits set to 0. So which is equivalent of taking the modulus. So you don't need to actually do anything for taking modulus. It is automatically modulus is performed, right? Uh, Let me directly show you the answer instead of like giving you the time for solving it and then we can stop. So here in this code, I have not shown the code snippet where we are initializing, where we are reserving the memory for A and B, right? So here I'm assuming that memory is already in the data section. We have reserved the bytes, 100 bytes for A and 100 bytes for B, right? So in the text section, I am defining this function do it. So first in X. I'll load it. I am loading the address of lower uh, lower 8 bits of the address of A. In XH, I'm loading the higher 8 bits of the address of A, right? So we are going to use the actually pointer registers. So in X now I have the address of memory location where A is stored. Then in Y I am storing the address of B by putting lower 8 bits of B in YL and higher 8 bits of B in YH. Then I am putting 100 in R16 to control the loop counter, right? And then I'm saying that first load from memory from the location Y plus, so Y R17, right? So what is Y? Y is pointing to the memory location which holds the array B. So I am actually saying hold the value, load the value from the first element of array B in R17. Then I'm incrementing that value by 1, and then I'm saying store R17 to X. So X is what? X is the address of the first element of the first address of the first element in the array A. So R17 is stored in A. But remember, when you use Y plus or X plus, what happens that value of Y or X is also incremented automatically. So now Y will be pointed to the next element in array B, and X will be pointing to the next element, that is element 2 in array A, right? And then I'm saying decrement R16, so it will become 99. So if it is not equal to 0, then go back here. So now what will happen? That value of the second element of array B will be loaded in R17. Then we are incrementing it by 1. And then we storing that incremented value in the second element of the array A. And we will do this 100 times until we are done with all the elements of the both of the arrays, and then we will return. Any questions? No? Okay, if no questions, then let's stop here. And uh, good luck for the exam. If you have any questions related to exam, or like you are free to send me emails, or even like if you have some difficulty in understanding the material, you can send me emails and I will try to respond. Or if you need like let's say if you need to have a Zoom meeting with me, I can also do that, but please send me an email at least one day before the day when you want to have the Zoom meeting to understand some material which is not clear to you. Okay, so good luck for the exam and see you then on the exam day. Bye. Hmm.